Electric force and Coulomb's law. You know that there are two types of charges, positive charges and negative charges. When these electric charges come close to each other, an electric force appears between the charges. Attractive force occurs between different charges, positive and negative, while repulsive force occurs between similar charges, negative with negative or positive with positive. In this video, we will learn about the factors that affect the electric force between charges and how the scientist Coulomb formulated his law, which determines the magnitude of electric force between point charges. Factors that affect electric force. Coulomb found that the electric force, Fe, between 2 point charges is proportional to many factors that include 1. The magnitude of the two charges, Q1 and Q2. Therefore, changing the magnitude of one or both charges will affect the electric force magnitude between the charges. The charge's magnitude is proportional to the electric force value. So if the charge's magnitude increased, the electric force will increase. Coulomb also found that the electric force is also affected by 1. The distance between the charges. When the distance between two charges increases, the electric force between them decreases, and when the distance decreases, the electric force increases. The electric force between two charges is also affected by the nature of the medium in which they are situated. The electric force differs between two charges in air or in a vacuum compared to when the charges are in water. This depends on the property known as the electric permittivity of the medium, denoted by the Greek letter epsilon. The electrical permittivity of the vacuum or air is denoted as epsilon naught and is equal to 8.85 times 10 to the power of negative 12 Coulomb square per Newton meter square. Coulomb identified the factors that affect the electric force between point charges, and they are magnitude of the charges, Q1 and Q2, distance between the charges, R, the nature of the medium in which the charges exist, or electric permittivity, epsilon, expresses these conclusions mathematically, and this formula is Coulomb's law. F equals K per Q1 Q2 over R squared. Coulomb's law states that the electric force between two charged bodies is directly proportional to the product of the amount of charge acting on the two bodies, and inversely proportional to the square of the distance between the two bodies, where K is the proportionality constant known as the Coulomb's constant. The value of this constant is dependent upon the permittivity of the medium, epsilon. K equals 1 over 4 pi epsilon naught. In the case of air, the value of K is approximately 9 times 10 to the power of 9 Newton meter square per Coulomb square. Coulomb's law is often used as a type of algebraic recipe to solve physics word problems.